Hello pre-calc class, this is Mr. McAllen again, and we're going to talk about function transformations, and in doing so our objectives will be talking about the four basic functions, transforming them so that they move up or down, left and right, flipping the function over the x-axis or flipping them over the y-axis. So we first start out and we have our four basic functions that we talked about in class. We have the identity function, which is y equals x. We have the squaring function, which is the parabola. We have the square root function. Another function we're working with is the cubic function, x cubed. And the last function is the absolute value function. And that one looks I'm going to plot the origin point, and I'm going to plot the other 2 points. Basically, the absolute value function just looks like a V that has a slope of -1 on the left side and a slope of +1 on the right. So, and the function would be f of x is equal to the absolute value of x. And this function, now since we're writing with function notation, x cubed would be f of x equals x cubed. And I'll just write these other functions in function notation. Okay, so let's talk about moving a function up or down. So we'll start out with any one of the four functions, and we have to describe the function by how its handle moves. Now each one of these functions has a handle that are all at the origin. In the worksheets that we worked on in the last couple days, we were talking about moving the functions up and down. So for example, if I had the parabola and I wanted to take that parabola and say, let's say f of x normally is x squared, and if I made the function so that f of x, well, let's call it g of x, was x squared plus 2, that would result in the function moving up by 2 units. So I would take the origin point from 0, I would move it up 2, and all the points with it would also move up by 2. So you would end up getting a parabola. And it's also symmetric, so I should draw it so that it looks like a nice symmetric U. Let me try one more time. Close. Well, let's try one more time. Close enough. That's better. So now if we wanted to move this function, let's say we'll call it h of x, we want to move the parabola to the left, we would just add a value, x plus 2, on the inside of the function, and that would move our parabola to the left. So we would start out at our origin point, which is normally 0, 0, and we would go to the left by 2. So I would go to the left by 2, and my origin point would move there. And then if I put in -1 and -3, my parabola would have moved to the left. Okay, now the way that you can remember this is whenever you take the inside information from the function, the expression that's inside being squared, you take that and set that equal to 0, and when you solve it, you find out exactly how it's moved, to the left or to the right. If it's -2, as it shows here, it's moved left 2 units. Let's go on to another function. Let's consider we have a combined motion, but we'll use something like the square root of x. So let's say I have f of x equals the square root of x, and I should remember that my parent function, the function that has no movement at all, starts at 0, 0, 1 at 1, my function's at 1, and when I go all the way to 4, my function has a 2 value, giving it this parabolic shape that's on its side. This function here would be the square root of x. So I'll just label that. Now let's say I have a combined movement. Let's say g of x, and someone's trying to trick me and they say it's got the square root of x plus 3 minus 2. That would move our origin point. It's going to move in two directions. I'll just label this in red, and it would move down 2 units, and this is saying that it would move left 3 units, because when you take x plus 3 and set that equal to 0, you get x equals negative 3. So on my graph, I'm going to just paste out 3 tick marks, and all these points are going to move 3 units to the left, and I'm going to move down 2 units. So, and I'll use a green marker to note down 2 units. So we'll go down 2 units. So I'm going to be right on top of what I just drew here. So and when I draw my parabola, let me make sure I have that right. Actually, that should be right here on, because this point was at in red, that was at positive 1 comma 2. So now when it's moved down 2 units, it should be here at the origin. So this is how my new function should look. And I would write right next to it that this is g of x, which equals the square root of x plus 3 minus 2. Now let's consider this example. Consider the graph over here to the right. It looks kind of like the function f of x equals x cubed. Well, I have noted here in the example that this is the handle of the function, and we can see here that it's been moved right 2 units and up 4 units. So we should be able to come up with what the new function is. So we'll call the new function h of x, and that will be x, because we've moved to the right, it's going to be x minus 2 cubed, and because we've moved up, it's going to be plus 4. Now on the SAT, they could also represent this, or in any other math class, we could also represent this as in terms of f of x. Because we said f of x is x cubed, we can simply call this f of x minus 2 plus 4. We don't have to worry about the cube, because when we say f of x in this notation, we're referring to our original function moving right 2 up 4. I hope this video was helpful for you, and tomorrow I plan to go over in class a short lesson on vertical flips and horizontal flips, as well as how we incorporate those with translations. I'm running out of time. It's like 9 minutes into the video, and I promised you guys that I would keep it under 10. So hope you guys find this to be helpful, and we'll talk tomorrow. Take care.